All right, so we will go ahead and start. Again, as I said, good morning. My name is Shei Shibore, and I will be taking you through today's webinar. So first off, I'd like to begin by just doing some quick housekeeping here, talking about GoToWebinar. So the way this works, all attendees are going to be muted, so I'm the only one that can speak, just so that there's no crosstalk. And sometime close to the end of the webinar, we'll have some time for questions and answers. And at that point, I will read out the questions and then answer them, either live right here on air, or I'll follow up with whoever asked the question after the webinar if it takes too long to answer, right here on air. But the main thing I want to talk about with regards to that is if you have any questions, you can write them in the GoToWebinar pane of your, I guess, on the questions pane of the GoToWebinar control panel. So you don't have to feel like you have to, unmute yourself to ask the question, by audio. You can just type your question into the questions box over there, and we'll be able to hear it, I guess see it from my end here, and respond to that as well. The other thing is this meeting is going to be recorded, and so at the end of the recording, we'll make sure we put this up on our YouTube channel. And so you can always search YouTube, Boundary Systems, and see not just this particular webinar, but every other webinar we've done for the last 3, 4, 5 years now already. Cool. So go ahead and dive right in. This is going to be, the general agenda. So, typically we're just going to be looking, I guess, today at, how Creo Flow Analysis helps in product design, how it makes it easy to use. And we'll start with a quick introduction of Boundary Systems and who we are. And then we'll dive into looking at, Creo Flow Analysis from a perspective of A, what are the challenges to flow analysis? B, what solutions does Creo Flow offer, and what are some of the capabilities that come with Creo Flow? And then finally, we'll dive into a quick product demonstration, and then we'll get to some questions and answers at the end. All right, and I guess also part of by way of introduction, I'll introduce myself really quickly here, Shei. And I've been with Boundary Systems, for over 7 years, and again have over 7 years of experience with PTC products. One of them being Creo Flow Analysis, and so yeah, again, that's me. Next is going to be a quick introduction about Boundary Systems. So we are a product development consulting company based out of the Cleveland, Ohio area, but really we have a reach that's global. So really, I like to say we help all of our customers reach higher levels of success regardless of where they are and what their product development challenges are. And a few more slides about us as well to just talk about, again, how fast we've grown, in the last few years, and also, the major accreditations that we have with many of our software support partners. And again, for us, at Boundary Systems, we pride ourselves in not just being, tied at the hip to PTC, but really we offer many other software solutions to our customers that may or may not be PTC solutions. And so for us, the goal is not necessarily to just, sell PTC software. The goal is more so to help our customers by giving them the best software solutions to meet their needs, PTC or not, right? And so in this case, we partner with many other software companies, again, to help our customers, with their product development challenges. All right, so one of those, challenges in this case is going to be, flow analysis, right? And so diving into this here, again, some of the typical challenges of early flow analysis, design will be an inability to mitigate risk and get a very good, early confidence in your design, right? Especially if, for example, you're unable to visualize a flow, over, your particular design, right? Or if your product involves some flow, you're unable to know, for example, what changes in the model geometry will result in, a corresponding, increase in, something beneficial, or decrease in stress, or decrease in weight, for example, or decrease in, pressure, or things like that, you can then use to inform your design and make a better product, right? The inability to see those kinds of things, from the front end, especially maybe if you're prototyping, for example, or maybe also, if you're using a mechanical simulation solution, means that, sometimes you can have, sometimes you're basically flying blind in terms of designing a solution, but, not being able to test it out, virtually to make sure that it works, and a lot of people will then, lean on physical testing, which then means, that's spending a lot of time and budget in order to quantify, their design decisions that way. And again, all of that, physical testing, can be drastically reduced, maybe not eliminated, but drastically reduced by the use of CFD software, right? And so really that's what the solution is here. So the solution is Creo Flow Analysis, right? So it's basically the ability to simulate and visualize fluid flow across your entire product design, right? This doesn't matter if it's external flow or internal flows or different kinds of fluids or different kinds of applications like electronics cooling or multi-phase fluids or things like that. Regardless of what the application is, if there's any fluid, right, that's again not solid, that's flowing, Creo Flow Analysis can analyze that, right? And which means then you can basically see the fluid to structure interaction of your products, and then redesign your products or optimize your products, right, in order to best take advantage of the fluid in which they're operating in, right? And so again, that means you're more so able to reduce your time to market. You're able to innovate faster as a result, right? And again, there are also going to be some cost and weight savings as well that could come along with a better product design, taking into consideration the flow analysis aspect of your product. All right. So Creo Flow Analysis is the solution for that. Creo Flow Analysis is a software that was embedded into Creo sometime, I want to say, around Creo 5, and the functionalities has been added to Creo 6 and also been ported back down to Creo 4 as well. And it's basically the ability to run full-fledged CFD analyses right inside of the Creo interface, right? You don't have to export this to another software package. You don't have to create STLs or step files or IGES files or things like that. Really, it's almost like the picture shows in here. It's seamless workflow between CAD and CFD. You have the same model in your same Creo UI in CAD, and with the click of 2 buttons, really. You have the same model in a very similar UI, but with different buttons that, in this case, allow you to run CFD analyses. Right. All right. So some of the other, capabilities and features of Creo Flow Analysis will be, for example, in this case here, very easy for you. It's very easy for you to generate the flow model. So Creo, and we'll show some examples in the demonstration portion of things, but Creo Flow has some very, very nice and simple features to allow you to very quickly create your flow domain, whether it's external or internal, without you having to spend the time to, select all the components and do a merge and do a solidify or things like that to cut out the, the solid volume from the air volume. All of that is done automatically for you, right? Also, one of the things that makes Creo Flow Analysis really stand out is the mesh generation, right? It's the fact that you don't have to be an analyst or an expert to be able to generate a mesh with Creo CFD and be able to run with it, right? And so in this case, there's very few settings or parameters that users can tweak, or I guess very few settings and parameters that users should tweak. The rest of it is done automatically, right? And that's one of the things you get from users that are trying to get started with CFD is, they don't know what button to push and how much to push it, right? And in this case, with a very easy mesh generator, Creo Flow Analysis essentially answers that particular question. All right, so another core capability of Creo Flow is, again, highly accurate results, right? And so it's the fact that we've been able to benchmark, Creo Flow analysis across, many different applications, many different verification models, and, in terms of, against, many different, software vendors as well. And in many cases, for the same level of model complexity, Creo Flow analysis typically excels when it comes to meshing time and also solving time, while also giving you highly accurate results as well. Right. So I'll quickly pause here and talk a little bit about some of the different packages that Creo Flow Analysis has, and essentially what's included in each package, right? And so the first is going to be, the base package, which, all of these base, plus, and premium allow you to, calculate internal and external flows. They're all going to run, a parallel processing. So if your computer has an 8-core CPU, Creo Flow Analysis can use all 8 cores. If it has a 32-core CPU, Creo Flow Analysis can use that. It doesn't limit you to how many cores you can use or not for simulation. And so again, parallel processing means your simulations can get finished much faster, right? Creo Flow also, allows you to, simulate, turbulence and heat transfer in all 3 modes as well, right? Now, some of the differences in the plus versus the base is you can also simulate, for example, particle motion, right? Radiation, and moving and sliding mesh as well. And so really a lot of customers that are looking for the plus are typically going to be doing things with maybe, for example, maybe the what's it called, turbo machinery, so maybe pumps, or things where either there's going to be some rotation or some linear motion of an object that's impinging on the fluid. Creo Flow Analysis can do all of that in the plus package. And then the premium package, in that case, what typically you'll see a lot of customers in that premium range is going to be typically the multi-phase, or multi-component. So in that case, you're looking at the interaction between gases and liquids, right? So, for example, sloshing in a tanker truck, for example. But again, aside from that, you can also look at cavitation, for example, in the premium license, as well as the dynamics portion of things. That's basically visualizing the interactions between fluids and solids, right? So if I have a ball valve and the ball valve is fully closed, right? The dynamics portions of things can let you know, okay, how much force is being impacted on the ball as the fluid is being stopped from flowing, right? So all those kinds of things you can see, in the different packages there in Creo Flow. And for this particular demo, we're going to be doing a few of the exercises, or I guess examples, that primarily look at the base package. But again, the ability to do other kinds of physics in the plus and premium packages are there, and they exist. And again, those are things that you can also take advantage of as well. All right, so at this point, I'll pause here for a second, and I'll switch my screens and dive into a quick product demonstration. So, and again, this is a good time to remind you, if you have any questions, you can put them in the questions pane of the GoToWebinar control panel. So that way, you can keep adding some questions, and then at the end of the webinar, we'll go ahead and answer all those questions for you. All right. So in this case here, what we have is basically a nozzle, right? So this is just 3D model of a nozzle, right? And this is assuming it's sort of similar to something where I assume a firefighter could hold a handle over here with a hose plugged into one end, and then accelerate the water out at the other end, right? And so right now all we have here is just a Creo model, right? We're going to go ahead and use this in Flow Analysis, or in order to get to Creo Flow Analysis, all we have to do is essentially click 2 buttons, right? 1 and then 2. And really, in 2 clicks, you're in a completely new, different interface, but yet it's still in the very same familiar Creo feel, right? You still have your your model tree section to the left-hand side. The only difference is now you have a flow analysis tab as well that's added in addition to your regular model tree, right? You still have the ribbon at the top with the tabs, right? The only difference is now there's a flow analysis ribbon with CFD specific commands that you can use, right? So again, all of this is something that, again, it's your, if anyone is familiar with Creo parametric or uses Creo, everything you see here, everything you're familiar with in Creo is going to have the exact same UI when it comes to using Creo Flow Analysis, right? All right. Now, one of the big things that's with Creo Flow, and one of the reasons why it's sort of been exciting and it's been improved since when it was released, is the fact that it now comes with a wizard, right? And essentially, this is basically you're essentially now saying that you have a wizard-based setup of your entire CFD simulation, right? From start to finish, you have a wizard that's guiding you through each and every single step of the way, right? So really, all setting this up now is as simple as hitting next, next, and next. That's really all you have to do as a user, right? And so again, that makes it your problem setup incredibly easy to use, right? There's not much, you don't have to you don't have to wonder if, oh, did I forget to add a certain step, or if I wanted to make sure A, B, C, D, and E are present in my simulation, did I forget to to specify C, right? Well, that's not going to be there, because the wizard essentially walks you step by step through, for any application you're working on, all the different critical things you need in order to get the simulation to run, and it's just a matter of hitting next and specifying each setting as you go along, right? And so we'll go ahead and practice through this particular exercise right here. So in this case, we'll start. I'll put my model over here on the right-hand side just so I can see it. Again, I can give my model, my CFD project, a name or a description if I want to, right? And then next over here, I can specify the physics that will be used in the particular model that I'm analyzing, right? So in this case here, I can just specify, okay, well, there's going to be flow of fluid, in this case water, through the nozzle. There's going to be some turbulence as well, based on how fast the water is flowing. And also, I want to show some streamlines to visualize the flow of the water as well, right? Again, you'll notice there's many other physics components that you can also add as well. And again, the wizard allows you to basically see a description of which of those components you're going to add, right? And it's as simple as left-clicking to add it or right-clicking to remove that physics component, right? But the fact that you're able to essentially pick and choose which physics to add essentially means that you're only solving for minimum complexity for any particular design that you have, right? So in this case, if I don't have heat transfer, then I don't need to add the heat component in, right? If I'm not solving for cavitation, I don't need to add that in, right? So essentially, this means the solver is much lighter because you're only solving for the specific physics that is currently applicable to your current simulation, right? So again, we'll say next. Do you want to set gravity? In this example here, we'll say no. But if we wanted to, it's as simple as hitting yes, and then the field opens up and asks us to specify a value for gravity. Again, if we say no, it's simple as that, it disappears. So that's the other thing about the wizard as well, is it's context sensitive based on what selections you choose, right? So again, specific selection means other fields may pop up to allow you to add more information, versus the no selection means, okay, you don't need to do that, we'll move on to the next item. Next, in this case, I'm going to create a fluid domain. We'll say yes, let's go ahead and do that. In this case, this is going to be an internal flow, so we'll go ahead and pick the internal fluid domain, and immediately it pulls us into our fluid domain creation tool, right? And in this case, and the fluid domain creation tool, again, it's very simple, very easy to use, right? It automatically figures out, where the openings of your model are, right? And based on those openings, right, I can go ahead and hit the green check mark, And Creo will then create the model to basically cap those openings, right? And then it creates essentially a solid part inside of your nozzle, right? Now, this solid part is essentially, if you could, imagine for a second, you have the water that's flowing into that nozzle frozen in time. This solid part represents that frozen water, right? But again, all I had to do to create this was 3 clicks, right? Nothing else, right? So again, incredibly easy to use, right? Saves you a lot of time. You don't need to, export parts or import parts into Creo. You don't have to, save something out as an STL or a step or an IGES. You don't have to, modify the geometry. You really don't have to, to spend any of that time messing with it. Really, you just, pull it into Creo Flow Analysis. It automatically, recognizes any inlets and outlets and just caps them immediately, right? And creates a solid part in there. All right, so next it says, okay, so we have a fluid domain. So now let's go specify the material for that. So I'll go add and say, I'll pick on this solid part in the middle here, our water part, or I guess what should be water. And go select on that and say, right now it's air. Sure, maybe we'll want, water to flow through that. So we'll, yep, there we go. Just had to scroll down. So that's water. And again, there's a default material list, but again, this material list is not by any means, exhaustive, right? You can also add any additional materials that are not in here as well, right? Next, we're going to go ahead and, okay, are there any inlet boundaries? We'll say yes. And so we'll go to the inlet portion, and that's going to be my inlet over here. So we'll leave this BC3, which is the bottom surface here, that's the one. So that's the inlet, and you'll notice it cross highlights between the wizard and the model as well, right? If I go ahead and pick BC4, it cross highlights the outlet over here, right? So again, this makes it easy to know exactly what you're clicking and see it, see the visual feedback in real time on your Creo model. So in this case, for the inlet over here, we'll go ahead and say there's going to be, probably we'll say 0.1 meter per second, water velocity through there, right? And we'll say yes, let's release streamlines. And for the outlet, we'll say yes, there's an outlet boundary. We'll do the BC4, and in this case, we'll just specify our boundary condition for the outlet. In this case, which is going to be atmospheric pressure, which is 101.325 pascals, right? And that's all. Right? So I want to specify other boundary conditions. We'll say no, and yeah. So again, it's just as easy as hitting next and next, or yes and no, and just continue on, right? One of the other things here that I will show is, for example, if I pick on this yes over here, for example, and I pick on this fluid volume to set up, initial condition parameters, we'll say no for this here. As I said, I want to specify some additional boundary conditions for the fluid volumes, right? Now in this case, it pulls out the options for me to specify whether I want to define this solid part as a heat source, right? Or as a moving component. In this case, basically like a piston, moving through a cylinder, or an inertial reference frame. So in this case, you could use this to solve a rotating turbo machinery like a fan or something like that, or a pump, right? Again, all of these options are all selected just because I picked on that, set volume condition, right? And in the case where I don't select on that volume condition, I don't see any of these, right? So the other thing that then makes this very easy is that, I don't have to be overwhelmed by 50 different buttons in my UI that say, then in that case, I'm wondering, okay, well, should I click this button or should I not click this button, right? That's not really there, because really all I just have to do is hit yes or no, and the wizard automatically picks and chooses what boundary conditions I see based on my selections prior to that, right? So again, this makes your setup much, much easier, right? And again, I'll just mention here the heat source. This would be for, in the case where you're trying to simulate some sort of conjugate heat transfer. So any natural convection or electronics cooling examples will typically have a heat source, in this case, where you can then pick on, for example, a CPU chip and specify a heat source value for that. So again, just as an example to show you how the wizard is incredibly smart, right? In that if I say no, It doesn't pull out those additional boundary conditions for me, and it just skips that and says, okay, if you don't need to set up a volume condition, we'll skip that, and you can go on to setting up the simulation. Over here, you can specify if this is going to be a steady state or a transient, simulation, right? In this case, it's going to be steady state, right? But again, we have the option to do both. And next, it's going to say, okay, it's going to have some initial condition parameters for mesh generation, right? And again, all of these are, fine-tuned to ensure that, for the default mesh works well for a variety of applications and models as well. When it comes to refining the mesh or tweaking the mesh, really, there's only two numbers to know. Really, it's just, this guy and this guy. It's just any of those two numbers, right? So it's just, the smallest element that you can create or the biggest element you can create. That's just it, right? Everything else you can just leave as default, right? And so what this means is it makes your mesh generation much easier to use. You don't have to figure out, you don't have to change 10 different knobs. You don't have to figure out, okay, am I going to add, a boundary layer? How many cells do I want in the boundary layer? Do I want to figure out the Y plus or all those kinds of things? You don't have to, think about all of that. It's just changing two numbers and that's it. And you're on to the next, essentially, right? Now in this case, you're ready to generate the mesh, so we'll hit OK. And all right, it's already done. And next, we're going to go ahead and, okay, so the wizard then says, okay, well, what kinds of outputs do you want to see, right? And I can do this a few different ways. I could, for example, specify outputs related to surfaces or boundaries, right? So in this case, we'll hit next over here. And over here at the inlet, we gave it a initial fluid velocity, right? And so now I want to know the static pressure at the inlet, right? If I already know the outlet is at atmospheric pressure, but I want to know the static pressure here at the inlet. So I'll hit next. And for pressure here, I'll say let's create a new chart to graph the static pressure at the inlet over time as it runs. If I want to add any other boundary conditions, or I guess any other output settings, it's as simple as going back here and adding any of these, right? If I want to add a monitor point to essentially, see, okay, what is the, the temperature at a specific point, X, Y, Z coordinate systems, I can do that again very simply by picking on this and then hitting next to add that in. Right? So at this point, we're done. So we'll go ahead and hit finish over here, and it says, do you want to run the simulation? Say yes. And it goes ahead and runs, and in this case, the model is small enough to where the simulation runs in less than a second, and we can go ahead and start to interrogate some of the results in here. Right? So, for example, in this case, we can go ahead and create a section view right through the model over here. Right? And in this section here, we can say, let's keep the drawing, and let's show velocity. Magnitude through the middle of this here. Yep. And we'll go ahead and hit OK. And yep, we can go ahead and see that, right? If we want to go ahead and see the mesh that was used to mesh this part on the inside, you can go ahead and turn on this grid from no to yes, right? And in this case, it shows you the mesh right there, right? Some of the other things you can also do as well, you can also, for example, show some streamlines as well. So in this case, I'll pick on the streamlines, and we'll go ahead and specify, in this case, a non-zero value for the animation time size, timeline size. And we'll say, for example, I want to color my streamlines by, maybe, for example, pressure, right? And in this case, you can see those streamlines essentially flowing from one end to the other, right? I'll go ahead and remove this this section plane just so that way I can see all the streamlines. Yep. And again, you can now see that very clearly here from from left to right, right? And again, to make the streamlines more visible, we can always do either make this bigger or smaller in terms of numbers, right, numerically, yep, and do something like that. And again, you can see how the streamlines are more clearly visible from inlet to outlet, right? Again, one of the other things you can also do in this is because we told it to create a chart of my pressure at the inlet, we're now able to, for example, pick on the XY plot over here and see, what the resulting, pressure is going to be. Right? So again, this means that it's very easy to, go from start to finish, just hitting next, and then, progressing through the entire simulation. All right, so I'll pause here, and we'll go ahead and show the next model that we have open here. So. All right, so next in this case, we'll pull out this truck model, and we'll go ahead and run some flow analysis on this truck as well. And again, just like we saw earlier, it's as simple as hitting 2 buttons to get into the flow analysis portion of the software, right? And again, we'll use our wizard, right? And again, for a truck, in this case, it's just going to be external flow over this truck. And so again, it's going to be the same, similar to the original setting over here, where we're picking flow, turbulence, and also streamlines. Right? We want to set a force for gravity. In this case, we'll say no. Gravity is not as significant of a factor when the truck is going at 60 or 70 miles an hour. If I want to create fluid domains, we'll say yes. And in this case, it's going to be an external fluid domain. Right? And in this case, we'll go ahead and select which parts you're going to be participating in the analysis. Right? So in this case, I'm going to pick everything from the tire and hold Control and pick, essentially to the trailer. Right? So essentially all the components you can see here right now. Right? All right. So, okay. Add those in, and based on all of that, Creo's flow analysis automatically creates a uniform bounding box, right? Relatively 0.5 of the size of all the way around the entire assembly of parts. Right? Now, if I want to, now in this case here, because our truck isn't riding on air, right? It's riding on the road. So what we'll do is we'll make this non-uniform, and we'll say, this over here, for example, should be 0. So that way. It shows the truck, riding on the road essentially flat. Right? All right, so we're done with our, flow domain, and then we'll hit next. And in this case, we can specify what material, the truck is going to be riding in, and I would assume in most cases it's going to be air. So we'll keep it at that. Next, are there going to be any inlets or outlets? We'll say yes, there's going to be an inlet. And in this case over here, it'll then basically show us the boundaries of that of the external flow domain that it created. Right. So in this case, this black outline over here is the boundary for the front of that box, right? And that's where air is going to be flowing in towards the truck. And so we'll say over there we're going to have normal velocity of about 36 meters per second, which is roughly around 65 to 70 miles per hour. And for the outlet, we'll say yes. And for this over here, we're going to pick the back as an outlet. We'll pick the top as an outlet, right? And we'll also pick the left and right sides of the truck as an outlet, right? You'll notice we don't pick the bottom, which is the road, right? Anything that you don't specify as an outlet will essentially have a wall condition, which is like the road. Right? And in this case, we'll say for that we want to do a specified pressure of atmospheric pressure, so 101,325. Right? Yep, no other surfaces to specify boundary conditions. And so we'll go ahead and just hit next and next, and finally go ahead and I'm going to generate the mesh. We'll say OK, and it goes ahead and does that. Now the mesh generation here is going to be happens decently quickly, and finally here we can then take a look at, for example, some results post-processing. Right. Again, I can say, for example, I want to see some results on some surfaces, right? And in this case, maybe for example, I can pick on the cab, right, of the truck, and I want to see, on that cab, for example, what the drag force is, right? So in this case, we'll basically specify in this case the pressure force in the X direction, which is this red arrow down here at the bottom right corner. And for that one, pressure force in the X, we'll create an XY chart for that one. And that's really all all I want to see here. And so at that point, we'll go ahead and hit finish, and yes to run the simulation. And again, very easily and quickly, you can start to see Creo Flow run the analysis. Right. Now in this particular case here, we'll go ahead and create a section view as well through this model. We'll say it's going to be through the Z plane, and we're going to show velocity magnitude over here. And you'll notice that right now the analysis is still running, right? Creo is still, trying to resolve this and converge, but again, you'll see the flow field starts to update in real time as the analysis is running, right? So again, if you, fail to specify a certain boundary condition, or you use the wrong sign, or the flow is, going backwards, you don't have to wait, 2, 3, 4 hours for a flow solution to finish before you realize your setup is wrong, because you can see the results happen in real time as the analysis is running. Over here I can pick on our XY plot, and I can see the drag force on the cab, and you can see as it starts to reduce and basically taper down at a or I guess converge to a specific value. The other thing we can also do here is, again, we could go ahead and release some streamlines. And in this case, what we'll do is something a little bit different. Instead of releasing streamlines from the boundary, like from the front over here, we'll go ahead and pick on the truck itself. And let's see. Say let's not show any pressure on the truck, but I want to release streamlines from the truck itself. So if I hit yes, right, then I can go to my streamline section over here and then define how those streamlines should be calculated or shown. And in this case, maybe for example, I'll color the streamlines here by velocity, right, magnitude, right. And now you can very clearly see if I set this over here to yes, and also over here on our truck, yep, set this to yes. And now you can very clearly see on the truck over here, streamlines that show, how airflow is, moving over this truck from start to finish, right? And you can, see areas of, for example, significant recirculation down all the way around the back of the truck over here, for example, right? So again, these are just some examples to show how you can use Creo Flow Analysis. How you can use Creo Flow. You can use Creo Flow Analysis to run CFD analyses right inside of Creo Parametric. Right? You still have the same familiar Creo Parametric user interface, right? But in this case, you can start to run some additional CFD type calculations in here. The other benefit to being in Creo Parametric and having a CAD embedded interface is, which I actually forgot to mention, is if I want to make a design change, right, it's as simple as, for example, going to my model tree and saying, let's go add a few more components which are currently suppressed, right? And so, some of you have probably noticed, let's see here, furnaces bodies. So some of you have probably noticed, in recent times that some trucks will have, this, hump over here at the top, right? Or sometimes the truck will also have these, baffles over here at the back, right? Or sometimes even, these skirts at the bottom, right? And so again, if you want to say, hey, what's the impact of those components on the airflow around the truck? It's as simple as adding those components in here, right? Adding them as a part of the simulation domain. We'll say, hey, let's go add our solid components, and in this case, we'll go add those three components as well, right? Say OK. Yep. And once they're added, all I have to do is go ahead here and hit Update Project and rerun the analysis again. Right? And once I hit Update, Creo Flow is going to go ahead and remesh the entire model again from scratch with those parts included, and then just rerun everything again. Right? And the same also works if you have a nozzle and you're trying to see, okay, well, what's the pressure if this orifice is, 3 inches wide versus 2.5 versus 2 inches versus 1 inch. And again, all those what-if kind of analyses, which prior to this you had no way of knowing or seeing how to handle inside of a Creo parametric. Now you can see the entire CFD analysis right inside of Creo parametric right here. Right? So that's one of the fantastic things about Creo Flow Analysis. So at this point, we'll go ahead and pause this right here, and we'll go ahead and switch back to my PowerPoint, and we'll take any questions that have come in so far. All right, so let's see what questions have come in. Cool. So I think so. The one question here is, what's the how does the accuracy of Creo Flow compare with the accuracy of other software packages, and really that's generally whenever we do any sort of consulting with customers, that's the one thing we always I guess people are always looking at is how does the accuracy compare. And the accuracy compares really well. And typically what we normally say is, you can bring us your model, right? And we can benchmark it against really almost any CFD package out there. And and we essentially will be really accurate to whatever numbers you have, right? Now again, CFD is a simulation tool which has approximations, so it's not gonna you're probably not going to be getting a man to the moon solely on CFD analysis alone, right? But again, you can get reasonably accurate very quickly with Creo Flow Analysis, even compared with other simulation packages as well. And, yeah. All right. Another question in here: do you have the ability to change units and mix different units? And the answer for that right now is no. So right now, Creo Flow Analysis only works with essentially the SI unit system. Right? And so there's an update coming for future releases somewhere in the Creo 7 or 8 timeframe where they will add the ability to convert units, but right now the answer is no for that. Right? And in this case, for me, what I typically just do is, I can always, pull out, MathCAD, right? If you don't have a license of MathCAD, you can get the free MathCAD, basically MathCAD Prime. Again, that's not MathCAD Prime. MathCAD Express or Prime Express or MathCAD Express is always going to be free, the Express version. And the free version or the paid version allows you to do units calculations very easily. So again, this is something as simple as if I say, hey, my air velocity is 36 meters per second. I can easily tell MathCAD, hey, let's take this and convert this to miles per hour, for example. It says meters per hour, and I can just change this to miles per hour. And I always forget what. Actually, that's just going to be mph. Yep, and that's 36 meters per second is right around 80 miles per hour, right? Which again is why I chose 36 for the simulation, because it's right around truck or highway speeds, right? So again, you can do all these unit calculations and conversions within a free MathCAD workbook, but again the embedded units conversions is coming in Creo Flow Analysis in a later version. Right. Another question here says, do you have the ability to select geometry, or do you only get to select from the listed surfaces? That's a good question. I believe the question is referring to whenever I am in the wizard over here, and I'll switch back to boundary conditions, which again, um, the, um, the beautiful thing about the wizard is it's not just static in that you just have to click next, next, next to the end. You can always click and go back to a new section, just to a prior section, and add something else or change something else. Or I can go over here to the boundary conditions section and modify the velocity, for example. Right? So you can always rewind back to another section and modify something in here. Right? For example, in this case, to the person's question, do you have the ability to select geometry? I believe that would be if you don't have any of the specific geometry you want to specify boundary condition for listed in this list. Yes, you can do that. So I can just easily hit add over here, right? And once I hit add, then I'm basically going to be selecting on a surface or a model, on a surface on the model directly, and then it'll add it as a new boundary condition for me. So I can either select from the list, right, which is predefined for me, or I can hit add and then select on the model myself directly. Either one would also work. Cool. Let's see. Any other questions? All right. If there are no other questions right now, we'll go ahead and end the webinar right here. Thank you so much for watching and being a part of today's webinar. And again, we look forward to seeing you on a future edition of Boundaries Webinar Wednesdays. Thanks so much for watching, and we'll see you later on. Thanks. Bye.